Let's practice solving linear systems by using the elimination method together. Now, in some previous videos and worksheets, I've gone over how to solve systems by graphing as well as substitution. So in these particular practice problems, let's focus on just using the elimination method. For number 1, we have the equations of 2x plus 3y is equal to 11 and negative 2x plus 5y is equal to 13. Now, to identify whether the elimination method is a good idea to use to solve for a system, we basically want to look for matching coefficients. Now, looking at the coefficients for the y terms, we have 3 and 5, and they're not the same and they're also not opposite, so that's not ideal. But if you take a look at the coefficients for the x's, we have 2 and we have negative 2. Those are opposites, and that is ideal for using the elimination method. Okay, so we definitely like this negative 2 and positive 2 for these coefficients, and let me show you why. Okay, so I'm just going to go ahead and rewrite these two equations. So we have 2x plus 3y is equal to 11, and then we have this negative 2x plus 5y, and that's equal to 13. Okay, so we have these two equations, and we do like the fact that this 2 and negative 2 are opposites to each other. Now, what you can do with these equations when they're lined up like this in standard form is we can add the equations or subtract the equations. Now, since we have opposites, we have a positive 2 and negative 2, what would make them cancel out? Well, it turns out if you go ahead and add these two equations together, if you add opposites, you always get 0. So if you add this positive 2x and negative 2x together, you're going to get 0. So we have no more x's, so they get eliminated. Okay, so we can go ahead and cross these out. Now, what happens when you go ahead and add this 3y plus the 5y? Well, 3y plus 5y is just going to equal 8y. Okay, so it's 8y. And then we can go ahead and add the 11 and 13 together, and that's going to equal 24. Okay, now at this point we just have a one-step equation, so we can go ahead and divide both sides by 8. If we go ahead and do that, then we're going to have y is equal to 3. So now we know what y is equal to for the solution of this system. Now, to solve for x, let's take this y value of 3 and either substitute it into the first equation here in this location or over here in the second one. It's totally your choice. I'm going to go ahead with the top equation just because we don't have any negatives there. So I'm going to go ahead and rewrite this. We're going to have 2x plus 3 times, let's see, we just found out y is equal to 3, so let's substitute that in, and then that equals 11. Okay, so 3 times 3 is 9, so we're going to say 2x plus 9 is equal to 11. Then we have a two-step equation here, so we can subtract 9 from both sides. If we go ahead and do that, then 9 minus 9 is 0, so we're going to get 2x is equal to 2. 11 minus 9 is 2. And then we can divide both sides by 2 here, and then we can say that x is equal to 1. All right, so that would be the other part of our solution. So the solution we got here is going to be the point 1, 3. This would be where the two linear equations intersect on the coordinate plane. Now let's go ahead and just check this real quick. This is our x is 1 and y is 3. Now checking for the first equation, let's go ahead and substitute it in for x and y and see what we get. So we're going to have 2 multiplied by 1, and then we're going to go ahead and add 3 multiplied by y. So it's 3 times 3. And hopefully this is equal to 11, right? That's going to be the goal here. Now 2 times 1, that's going to be 2. 3 times 3, that equals 9. And hopefully that's 11. So 9 plus 2, that is 11. So since 11 does equal 11, then this does work out for the first equation. Now let's just double check to see if this does work for the second equation over here. So that's going to be negative 2 multiplied by 1. That's what x is equal to. Plus 5 multiplied by, I think that's going to be 3, right? 5 multiplied by 3, and let's see if this is equal to 13. Okay, so negative 2 times 1, that's going to be negative 2. 5 times 3 is 15, so let's see if that does equal 13. Well, negative 2 plus 15 does equal 13, so if 13 does equal 13, then this checks out. So we're pretty confident here that our solution is 1, 3. Let's check out number 2. For number 2, we have the equations 5x plus 6y is equal to 50, and negative x plus 6y is equal to 26. So let's look for some matching coefficients or opposite coefficients here. If we take a look here for the x terms, we have a 5 and a negative 1 for our coefficients. Those don't match, so it's not ideal. But if we take a look at the coefficients for y, there's 6 and 6 here, so we do like that. So we can go ahead right away and start with our elimination method here. Okay, so let's go ahead and rewrite these equations. We have 5x plus 6y, and that's equal to 50. And then we have negative x plus 6y, and that's equal to 26. Okay, So let's go ahead and see what we can do to eliminate one of these variables. Now we identified that we like this 6y and 6y here, right? Just because they have the same coefficients here of 6 and 6. Now they're both positive. Now in the last example, we added these together. But in this case, if we add 6 and 6, we'll get 12y, which doesn't eliminate them. So in this case, let's go ahead and actually subtract these two equations together, since if you subtract 6 minus 6, you'll get 0, and those will eliminate, right? So if we take this 5x and you subtract a negative 1x, that becomes 5x plus 1x, and that becomes a total of 6x, okay? Now if we take this 6y and we take away 6y, that eliminates, which is the goal that we were trying to accomplish, and we don't have to deal with those y's anymore right now. Now on the other side of the equation, we have 50 take away 26. 50 minus 26 is going to equal 24, so this would be the equation that we could solve here, okay? We have a one-step equation. Let's go ahead and just divide both sides by 6. If we do that, we're going to find out that x is equal to 4. So now we know the x value for our solution. Now that we know x is equal to 4, let's go ahead and figure out what y is. So we can either substitute in this first equation or in the second equation. Now I think I'm going to go for the second equation. It has a negative in there, but I think it's less work that we have to do. So let's go ahead and substitute that in. So it's going to be negative 4, okay, and then plus 6y, and that's equal to 26. Now negative 4, or the opposite of 4, is just negative 4, so I'm just going to go ahead and write negative 4 there, and that equals 26. Now to solve this, we have a two-step equation. Let's go ahead and add 4 to the left side and add 4 to the right side. If we do that, then a negative 4 and positive 4 cancel out. We get 6y is equal to 30. Finally, we can divide both sides by 6 here. If we do that, we're going to see that y is equal to 5. So when x is equal to 4, y is equal to 5, and I think that's going to be our solution. The only point that would exist on both of these graphs is going to be 4, 5 over in quadrant 1. So we think that x is 4 and y is 5, but we should go ahead and check this to see if our solution makes sense. Let's substitute these into our first equation to check that out. So that's going to be 5 multiplied by x, which is 4 we got, plus 6 times y, so that's 6 times the 5 that we got. And we are hoping that this does equal 50, right? If it doesn't equal 50, then we made a mistake. If it does equal 50, then we did a good job. So 5 times 4 is 20, plus 6 times 5, that is 30. So we have 20 plus 30, and that should equal 50, right? So if 50 equals 50 here, then this works out. If we check this solution into our second linear equation, we can go ahead and substitute that in. So that's going to be negative, let's see, x is 4, so it's going to be the opposite of 4, plus 6 times 5, so 6 multiplied by 5, and that should equal 26, hopefully, right? So the opposite of 4 is just a negative 4. 6 times 5 is going to be 30. We're hoping this equals 26. Negative 4 plus 30, that does equal 26. So since 26 does equal 26, we can be more confident that this is our answer. Here's number 3. For number 3, notice that our equation's a little bit out of order. We have 11y minus 3x is equal to 18. Then we have this equation of negative 3x is equal to negative 16y plus 33. So neither of these are quite in that standard form that we are looking for. So we can go ahead and rearrange these equations so that they're a little bit more aligned to what we are looking for. So for that top equation, let's go ahead and just copy that down. We can write 11y minus 3x is equal to 18. Now, if we just rearrange the left side using the commutative property, remember this is the same thing as 11y plus negative 3x. So we can just turn this around and say we have negative 3x plus 11y, and that would be equal to 18. So now we've turned this top equation into this one in standard form. Now let's go ahead and take the second equation and copy that down. So let's go ahead and write negative 3x is equal to negative 16y plus 33. And so let's turn this into standard form as well. So if we go ahead and add 16y to the right side and add 16y to the left side, then we can see that we're going to have an equation in standard form as well here. All right, so on the left side, we're going to have negative 3x plus 16y, and that's going to equal positive 33. Okay, so we have these two equations now. They're both written in standard form. So we have negative 3x plus 11y equals 18, and we have negative 3x plus 16y is equal to 33. So now that they are in the same order, let's go ahead and line them up on top of each other. So negative 3x plus 11y is equal to 18, and then negative 3x plus 16y is equal to 33. Okay, now everything is lined up really nicely. Let's see if we can find some coefficients that are helpful. Looking at the first ones, we have negative 3 and negative 3, so we like those right away. Since they both happen to be the same number, if we add them, we would get negative 6, which is not what we want, so let's go ahead and subtract them instead, right? So negative 3x, take away negative 3x, you end up adding a positive 3x, so those are going to get eliminated, which was the whole point of this method. Then we're going to go ahead and take 11y, take away 16y. That's going to be negative 5y. Okay, so the left side just has negative 5y. And on the right side, we have 18 take away 33, and that's going to be negative 15. So we have a little one-step equation here, and we can solve for y by just dividing both sides by negative 5. If we go ahead and do that, then we're going to get that y is equal to positive 3. Okay, so that would be part of our solution. So now that we know what y is equal to, we can go ahead and solve for x. Now, my preference between using the top equation and the bottom equation, I'm going to go ahead and use the top one. Just looks like there's maybe some less things going on here, so I'm going to substitute that in. So let's say that's going to be 11 multiplied by 3. So 11 times 3, just like this, then minus 3x, and that should equal 18, right? Now 11 times 3 is 33, so we have 33 minus 3x is equal to 18, and we now just have a two-step equation. Let's go ahead and subtract 33 on both sides of this equation. The 33s are going to cancel out on the left side, so we're going to get negative 3x is equal to, looks like negative 15. And then we have a one-step equation. Let's divide both sides by negative 3 and negative 3. If we do that, we're going to get x is equal to positive 5. So that would be the other part of our solution. Putting these two pieces of information together, we get a solution here of 5, 3. This would be the only point that would exist on both of these linear equations or the graphs. So x is this 5 and y is this 3. Let's go ahead and just check to see if this works for both equations or both linear equations. Let's go ahead and substitute it into the top equation first. So that's going to be 11 multiplied by y, which is 3 that we got. And that's going to be minus 3 times x, so 3 multiplied by 5. And let's see if this does equal the 18 that's on the other side. So let's go ahead and check that. So 11 times 3, that's 33. And then this 3 times 5 is going to be 15. 33 minus 15, that does equal 18. So if 18 does equal 18, then we know we did a good job for this first equation. Okay. For the second equation, let's take this 5, 3 and substitute it into this equation. Okay, so we'll have negative 3 multiplied by x, which is 5, we think. That's going to be equal to, hopefully, negative 16 multiplied by y, which we got was 3, and plus 33. So let's go ahead and see if this is true. On the left side, negative 3 times 5 is negative 15. And on the right side here, negative 16 times 3 is negative 48. Negative 48 plus 33, that's 48 minus 33, which is 15. And it's negative, so negative 15 does equal negative 15. So this does check out as well. So we can be confident that our answer is correct of 5, 3. Here's one more example. Let's check out number 4. For this one, we have the equation negative 5x plus y is equal to negative 23, and negative y is equal to 3x minus 9. So this first equation is written in standard form. We have x, then we have y, then we have a constant. But the second equation is not quite in the order that we would like it to be in. So let's rewrite the second equation. So taking the second equation and just rewriting it, we'll have this negative y is equal to 3x minus 9. And let's get the x's and y's together here. So let's go ahead and take away 3x from the right side and take away 3x from the left side. So we have x's and y's both on the left side. If we go ahead and do that, we're going to get negative 3x minus y is equal to negative 9. Now, if you wanted to, you could definitely multiply everything by negative 1 just to rearrange this and have more positive coefficients, but it's really not that necessary. So let's go ahead and just copy down this first equation that's in standard form. That's negative 5x plus 1y is equal to negative 23. And let's take the second equation that we just rearranged here and write it right beneath it. So we'll have negative 3x minus 1y is equal to negative 9. Okay, so this would be our system, and everything's lined up here just because it's in standard form. Now, should we eliminate the x's or the y terms? Well, our x coefficients are -5 and -3, so they're not opposites and they're also not the same. But you can notice here that for y, we actually have a +1 and a -1 coefficient. So if it's helpful to see that, I'm going to go ahead and write a +1 and a -1, just kind of make them light there. So they're not really there, but you know they're there. If we go ahead and subtract these, that wouldn't eliminate it. We would get 2y. So let's go ahead and add them. Remember, when you add opposites, you get 0. So +1 plus -1 equals 0. If we add this -5x plus -3x, that should equal a total of -8x. And if we add the +1y and -1y, those are going to eliminate, which is what we were hoping for. And then -23 plus -9, that's going to equal -32. All right, we have a nice one-step equation here. We can solve for x by dividing both sides by -8. If we do that, we're going to get x is equal to +4. So that's going to be part of our solution. Now we can take this x equals 4 and solve for y. You can either plug it into this top equation over here or this bottom equation over here. The bottom one looks like it might be a little bit less work. I'm not sure. The top one is totally up to you. Actually, I like how the y has a positive coefficient on the top one, so I'm going to use the top one. So let's go ahead and write it as -5 multiplied by 4. I'm using the top equation, plus y is equal to -23. So -5 times 4 is -20. So you have -20 plus y is equal to -23. Yeah, I think I like this one more because we have a positive y. And then we just have a one-step equation here. So let's go ahead and add 20 to the left side and add 20 to the right side. If we do that, that -20 and +20 are going to cancel out, and we're going to get y is equal to -3. So that would be the other part of our solution. Putting these two pieces together, we should get the solution is going to be 4, -3. So the point at which these two graphs intersect would be over in quadrant 4. Okay. Now again, this is our x, which is 4, and our y we found was -3. Let's go ahead and check this to make sure we are certain that this is the answer. Let's go ahead and plug it into the top equation first. If we do that, we're going to have -5 multiplied by x, which is going to be 4, right? And then plus y. Y we got was -3. Let's go ahead and put that in parentheses, give it a hug, and that's equal to -23, hopefully. Now -5 times 4 is -20, plus -3 is really, I'll keep it the same just because I like adding two negatives more than subtracting them. And so we have a negative plus a negative, so -23 on the left side does equal -23 on the right side, so I feel pretty good about that being true. Now let's go ahead and take this solution and substitute it into the second equation here. If we go ahead and do that, we're going to get negative, let's see, y is equal to -3, so -3, give that a hug, is equal to 3 times, what do we get for x? 4. And then hopefully that's going to subtract 9 and make this true. So on the left side, the opposite of 3 is just going to be 3. Let's see, on the right side, 3 times 4 is 12. So what's 12 minus 9? 12 minus 9 is 3. Good, so 3 equals 3. And so this also works. So there you have 4 different practice problems on solving linear systems by using the elimination method. Keep in mind, we do like to have everything lined up, so standard form is pretty standard, and you want to line up your x's and your y's and your constants. Make sure that you either have the same coefficient or the opposite coefficient, so you could add or subtract to make sure you eliminate one of your variables. Solve for the one that you didn't eliminate, and then substitute it back in to solve for the other one that you still need to know. Okay. If you found this video helpful, please consider giving it a thumbs up. Remember, you can find a blank copy of this PDF worksheet in the description box below, as well as the answer key PDF in case that's helpful. As always, keep up the great work, and I'll see you in the next one.